Okay, so what I'd like you to do first is go ahead and fill in the slope fields for x, y over 2. Please fill in the slope field for x, y over 2. Should look something like that. Go ahead. Well, you know the coordinate like 1, 2 and 2, 1 are going to have slopes of 1. Okay, I would go to those. Any coordinate with a 2 in it, you know, you're going to get to reduce. On the AP test, if they ask you to do this, they'll give you like 9 coordinates. Okay. Maybe 12. So in part B, write an equation for the tangent line to the curve y equals f of x through the point 1, 1. Then use your tangent line to estimate the estimate of the, you get it. I'm going to have to erase this so I can scroll down. Are you okay with that? Is there a problem?
My eye itches, so no.
Okay. So we want the tangent line equation through 1, 1. Before we can write a tangent line equation, what else do we need? We need point and slope. What is our slope at the coordinate 1, 1? Okay. So our tangent line equation is y minus 1 equals 1/2 times x minus 1. Okay. Now what's nice about this is they want us to estimate f of 1.2. What does that mean we need to do? Plug in 1.2. Don't get too complicated here, buddy. We have numbers to work with here, okay? So if we plug in 1.2, that's a 2. What is 1.2 minus 1? Oh, times 1/2. Point one? Point two divided by 2 is 0.1, right? Maybe. So when we add over that 1, we get 1.1. So f of 1.2 is approximately 1.1. That was supposed to be squiggly. Now, I am asking in part C for the particular solution. What does that mean we need to do? Particular solution. Okay, and what do we need to do before that? Okay, and before we integrate.
Isolate.
Yeah, boy.
Isolate what?
X.
Oh, we need to separate. That's the word I was looking for. We need to separate our variables. The y needs to get divided over. Oh, up in this. The y needs to get divided over. And what is x over 2? X over 2 gets to stay, but then the dx gets multiplied over. Okay, remember the separating variable stuff that we learned on Thursday? Okay. Blue? Blue sound good to you? Okay, so now we're going to integrate. When we integrate 1 over y, we get the natural log of y. And when we integrate x over 2, we get 1/4 x squared plus c. Okay, we need to solve for y. So since we have the natural log of y equal to all of this mumbo jumbo, I'm going to exponentiate both sides so that the e to the natural log cancels out. Okay, and we have y equals c e to the 1/4 x squared. Oh, this is really not like, this is an e. I know, my y looks like a, he has a mustache or something. Okay, questions to here? They did ask us for the particular solution, which means we need to go back and do what? Solve for c. So we know that our coordinate is 1, 1. F of 1 equals 1. So y is 1 when x is 1. So c would equal e to the negative 1/4. Because I have 1 divided by e to the 1/4. So 1 divided by e to the 1/4. I'm going to move the exponent up. Oh, you heard an extra 1 in there?
Yeah.
Okay.
I thought you were still doing 1 over it.
So you thought I was crazy, right? Okay? So now we have y equals our c times e to the 1/4 x squared. Okay, is there if we have the same base, we can add our exponents together, right? This is e to the negative 1/4, and this is e to the 1/4 x squared. So I'm going to write x squared minus 1 over 4 as I add those two fractions together. Now, if you write negative 1/4 plus 1/4 x squared as your exponent, that's fine. If you write x squared over 4 minus 1/4 as your exponent, that's fine. I have just made the decision that I really like them to be all clumped together as one fraction for my exponent.
So
I'll do
were
the
we
same
not
thing.
supposed to use our calculator?
No. I do not want the decimal. Okay? Now, I will let you use your calculator to find f of 1.2. So you can have your calculator out and go ahead and plug in 1.2 for x. You have a question? Okay. Yeah. I'm enjoying all of these different colors that I can use
We use rainbow next.
here. Sure.
I got it.
F of 1.2 equals 1 point what?
1,162.
Okay. 1.116. I don't have the room that you have to write. Okay. Okay. Well, we know which one is bigger, which one is smaller, but we wouldn't actually have to have the value of f of 1.2 to know. Okay? If we compare B and C, we estimated f of 1.2 to f of 1.2 to equal, was it 1.1? And here, f of 1.2 is actually 1.116. It is an underestimate. How do we know that with the calculus that we have?
The slope field shows the graph is
Yeah.
The slope field shows that the graph is concave up at 1, 1, which means the tangent line that we created sits where? Below. I'm processing the same as you are. Okay? So our tangent line sits below our curve, which means the tangent line estimate was an underestimate. And that's what you would need to write up for part B. Okay, let's talk through that again. Our slope field shows that our curve is concave up at 1, 1. So our tangent line sits under the curve, making our value an underestimate. Well, so this really was my plan.